All right. Let's see if anybody shows up. Close that. That. I got 8 viewers? Sweet. Is that right? What up? Gang. Can y'all hear me? Tell you what, this is a quick way to find out. Gang. Can y'all hear me? Yep. You can hear me. Cool. What up, chill bro? With a 0. Like your name. Do you live up to your name, chill bro? Are you a chill bro? Bro? Let's turn on some music. What do we want? Let's try electronic. What's up, Sangren? How's it going? My most loyal fan and follower. Appreciate you. Love having you on. You're not a chill bro. It's cool. I get it. Yo, I'm not hearing nothing. Oh, it's probably because that mic could be I don't have Spotify open. Is that what's going on here? Do your job, bro. Frickin' scuffed already. Off to a great start, huh? All right, let's try this again. Spotify. Electronic. Hey, Lamau. A Vox will take over. I know how to pick them. Can I gloat for a second? Can I gloat? I saw Ethereum coming. Saw it real early. Pissed off I didn't get the pre-sale wallet, but did buy in at $2. Knew Ethereum's gonna be a thing. Very happy about that. Jumped into that space. Then I saw this. This is coming too. It's a matter of time, boys and gals and toaster ovens. It's a matter of time. We're gonna take over the world. Avalanche is gonna be the greatest. Everybody's gonna want to be part of the Avalanche community. They're gonna be building like they've never built before. Transaction speeds at over 4,500 TX per second. Finality in often under a second. Quiescent, green, proof of stake, low barrier to entry. You name it. Everything you've always wanted, everything you've dreamed about, every promise that's been sold to you that never delivered, Avalanche delivers. Come, be part of the Avalanche community. Join us. That's some marketing material right there, boys. All right. No, I didn't know there was a Wolfram Distributed Systems stream. I know that Sangram has been talking about how the stuff that that Total Not Charlatan Stephen Wolfram has been jabbering on about. I'm kidding. It's just easy to pick on him. He's actually really brilliant. I mean, anybody who gets letters responses from Feynman is smart in my book. But yeah, some of his ideas are just, what are you doing? But apparently he stumbled upon Avalanche almost independently. That's what it looks like. It looks like he's sort of stumbled on Avalanche through his whole, like, you know, what's that stuff called? The grid thingy, like the Game of Life stuff that he really loves. I mean, it works. It makes sense that he would actually find that, because it's not exactly unrelated, you know? Yeah, actually, yo, it's funny. I just got affiliate, So that means I could get better emotes now. But like, unfortunately, I got that like 45 minutes before the stream. Like, I got notified that I was all happening, that the payment blah 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 set up and yada yada yada. All right, look. So I'm not in this for the money, but every time you subscribe, it helps my social rank. So like, let's, I appreciate if you got like a Twitch Prime or something. It's free. I would totally accept it. But yeah, I mean, like, I got affiliate like literally earlier today, and with that comes new emotes and badges. All that stuff I got to set up. I might be doing that this weekend. Probably won't be ready for tomorrow, but it's definitely something that I'm looking forward to. Cellular Autonoma. Thank you. Automata. Automata. Cellular Automata. Cellular Auto Tomatoes. Yeah. I'm a dork. I'm such a dork.
It's over 9,000!
Jeez Louise. Anyway, it's not shocking that he actually stumbled upon some of this stuff. If you look at the work that Ted Yin did on this, like Malfin Yin, he's by the way, Ted Yin, for those who don't know, is a co-founder, early stage in the company. I guess it's fair to call him a co-founder. I don't know if that's an official title. But he was like one of the first to actually build a full-scale like network proof of concept on Avalanche to show that it actually worked. He's also the first person. He's the first author on the Hot Stuff white paper. And so as it's explained to me, the way that first author works is the person who does like the work to actually implement it, and is like the student who's like the prime lead on the project goes first, and then in computer science papers at least, and then the last person on the paper, Dahlia, is the person who actually came up with the idea and is the professor behind the project. So Dahlia is kind of like the sort of like inventor, and then Ted Yin is the implementer. But of course, in the process of doing that, you have to know it and learn it. And like, of course, she says, go do this. And he proves that thing's true. So there's a lot of like, those are the two main people on the project. And Ted's the person who built Hot Stuff. Now, Hot Stuff is going to be the consensus protocol that our beloved Facebook was using for Libra. There's a classical consensus protocol. It's an optimization on, other protocols, basically. It's not really, I mean, I guess it is signature aggregation and stuff, which, by the way, I mistakenly corrected Zaki one day on Twitter and said Hot Stuff has nothing to do with like your guys' work, and then he was like, nah dog, actually we gave the inspiration, Zaki Mannion, a lot of us gave the inspiration for Hot Stuff, which then Dahlia went and formally proved, and then Ted and Dahlia built. So oops, I did not know that. I'll eat crow about that one, I don't mind. But either way, signature aggregation stuff, I don't know the whole details of it. I never finished reading it. But that tells you where I am. I'm not a consensus protocol expert. I know things that I've learned through the lab. That's who I am. I'm very practical. If I don't need to know it, I don't tend to go out of my way to learn it. That's not true. To some degree I do. But that's why I know Avalanche consensus. So that's why you're here today. Learn more about Avalanche in general. I've dedicated a whole day to this. I will say that I'm probably not going to continue. I don't know. I'm debating whether or not I continue the Technical Wednesdays, just because one, it's lower viewership, which is not good for me, but also it's because I don't know how much longer I'll have things to contribute in that respect. I left the tech team. Like, plus I was never like the strongest engineer to begin with. I'm not the best engineer. I'm just a guy who can code, who's got a lot of years under his belt. I've never been passionate like some of these folks have about engineering. So I'm a hard-ass worker. I work probably harder than most anybody. I go 100% all the time when I'm going. But I'm not the guy who's going to go deep on a lot of things. Like people like Tyler and Steven and Ted, like they're going to go real deep. They're going to go really deep into a subject matter. But I left Avalabs. I'm very open about this. I left Avalabs because I was burnt out. I couldn't keep going. And I didn't see any way to stop it. Like, there's no way to stop it. And it just became, when you get burnt out, you start acting out. And when you start acting out, humans are messy. It's like, that's just the way it boiled out. And so there's really nothing else to say other than like, I was really just tired. I still talk to Goon and Kevin, Steven and such. Like they're all great folks. Like I talked to Philip Liu, my roommate. We set up a company flat in Williamsburg, and Philip and Steven and I lived together in that flat. I was kind of like den father, I guess you could say. I don't know, cub master. I don't know. That's rude too. But yeah, basically, I helped them set up the flat and get that going. Made sure that everybody could stay as distraction free as possible. But it was burnout. Like literally, it was burnout. I was doing too much. I was overextended, and I snapped. I couldn't keep going, so I turned in my resignation. I couldn't keep it up. I mean, just to give you an idea, basically I took almost no vacation time. The times I did take vacation, it was Christmas and for 2 weddings. And that's okay. The project needed to happen. But I was working 9 a.m. to 10 to 2 a.m. every single day, including weekends. I felt guilty if I took some time off in the afternoon to go play a video game. Like, that's where I was. So, that's unsustainable. And I couldn't keep it up. So that's why I left. It had nothing to do with anybody else but me. And it was the right call. It really was. Really was the right call for me. So that's why I left. But, in the process of working there, I learned a lot. That was one hell of a crash course. I am not a master's. I don't even get a master's degree. I have a bachelor's in computer science. I had a podcast where I learned a lot about the terminology and the terms about this stuff, enough to spot what Avalanche was. That podcast is still running. It's called Hashing It Out. Corey Petty is running it. Good friend of mine. We hang out on the Slack all the time. So definitely check out that podcast. It's a very deep technical podcast. But when Corey approached me, he was like, I want to do a podcast. I was like, okay, I want to do something on the social change around blockchain. He's like, I want to do something technical and I own the network. It's like, okay, fine. So we did a technical podcast. But I'm not that deep of an engineer. I know enough. But because I was so surrounded by deep engineers and the really, really bright guys that came out of Cornell, I could maybe help a lot of you understand a little more about Avalanche itself, what it can do, what it can't do, what consensus really means. I'm good at translating really smart people. I'm also smart, but in my own way. I can translate a little better if I take a little time and work on it, eventually get a narrative that people can understand. And that's something I hope to bring to this stream. Some of these topics get a little heady, and you get bogged down by the details, and the details don't matter. And the fact that I don't care about them really helps you guys, I hope. Really. Getting back to this other thing we were saying, Wolfram. It's not a real shock that Wolfram decided to, almost seems to have independently come to Avalanche consensus. He almost looks like he independently came to figure out that Avalanche consensus is a thing, that it works. That's what it looks like. He independently figured out that he could color this whole grid the same color, or independently. Now, Wolfram's a really smart guy, but I guess his cellular autonomous stuff is really out there, and calling it a new kind of science is an interesting marketing approach for something that's not really all that new. He independently looks like he independently proved Avalanche. Which is freaking cool. It's really, really cool. Look at this. This is literally if a cellular autonoma, basically, when you look at it, automata. Look at this. This is a simulation created by Ted Yen. I'll paste this in the chat. It's so beautiful. Oh, snap. Yeah, that would help. Thanks, pal. All right. Let me do this again. So I gotta Just stream fail. Scuffed. Alright, so like this is something made by Ted Yin. And it's a simulator for Avalanche. And I just pasted it in the chat. And like this this looks exactly like Wolfram's work. Like there's no doubt. This looks exactly like Wolfram's work. It really does. Like it's probably not a coincidence. It probably is not a coincidence. So like I'm really excited to see another person independently come to the conclusion. It looks like it's independent. Like came to the conclusion that Avalanche works. He didn't know what he was doing from what I read. Like he doesn't know consensus. He didn't use any of the terminology. Is it in 2 hours? I could totally do a live stream watch. I don't mind that. I hope I don't get like I'd have to like end the stream and restart it so that I don't get like DMCA'd. Like I could then delete the stream and then move on. But you know, I mean, like it looks like he independently came to the conclusion that Avalanche might work, and that's cool. Like the fact that somebody could do that stuff. Yes, he did not use consensus as his frame of reference. Like he kind of did, but like he didn't talk about trade-offs like safety and liveness, blah, 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 blah. Like, he didn't talk about the actual problem of consensus protocols, but he did show that he could color the whole map with the same a similar process that we have, which is neat. It's very neat. I just picked my ear on stream because it was itchy. Wow. I do not care. Yeah, Wolfram does see himself as a new Von Neumann. I don't know why. He hasn't like done anything but write books. Like nobody can practically apply his work very well. But you know, this might be one practical application. It just came out before. So all right. So look, this is what Ted Yin built, and you guys didn't get to see it yet. But if I hit run, it'll run a certain number of ticks of this simulation. Oh, it might help if I hit reset first. Okay, if I hit run, it'll run a certain number of ticks of this simulation. And it shows that with the proper configuration, the network quickly cascades into consensus on a color, right? And this is using 2 different colors. Now, this will probably stop before it finalizes. Yeah, so it stopped. There's still 3 little squares here. It might be hard to see on stream, which aren't exactly dark blue. But if you hit run again, it'll continue the stimulation for a few more steps, and then you'll see they quickly come to the same conclusion. So this is Avalanche. This is what Avalanche does. Like, and if you look at the work that Wolfram has recently pumped out, it looks like this. This is what he did. But this was done years before Wolfram. So clearly, I think he might have stumbled on it, which is great. It's secondary validation. I love that. And you hit reset, you hit run. It shows everybody's in disagreement. Which color is correct? Which color are we going to pick? And then you see, like, slowly, like, it starts coming to consensus, and everybody just starts moving towards the orange. And then the whole grid becomes orange. Ta-da. See, this one actually finished within the set number of steps. So that's literally exactly Avalanche. It is very similar to Avalanche, but a new kind of science is not consensus. Is not actually what we have here. Actually, what's NKN? I read that as new kind of science for some reason. What is NKN? I'm not really sure. Anyway. I'll tell you what, it adds weight to Wolfram and it adds weight to Avalanche. That's the way I look at it. Anything that adds weight to what we're doing, that's great. Love it. Love it. So let's talk a little bit about what's going on here. Obviously, there's some parameters here. We're going to ignore that. New kind of network. Interesting. Let's go over Dan Lane's work. For those of you that don't know Dan Lane, follow him right now. Twitter.com. Dan Lane. Dan Lane and I have not always... This is my incognito window, so I'm obviously not following anybody here. But Dan Lane and I have had many a rough argument. But in the end of the day, we always seem to come to consensus on how we're going to move forward. Dan's a smart guy. He's a smart guy. Very smart guy. So, follow him. Smash that like button and subscribe. Speaking of smashing that like button and subscribe, can y'all do me a little favor here? I need more followers on my YouTube channel. I only got 101. I should have crossed the threshold by now where I could actually say, hey, yeah, I've got enough followers I could get a custom channel name, because this channel name's gross. Look at that. It's ugly. It's an ugly channel name. I don't want that. I want a pretty one that says youtube.com/channel/Colin Couché, right? But I can't do that because YouTube requires me to have at least 100 subscribers before I can actually do that. So smash that like button and subscribe, and ring that bell so I can get that pretty channel name and start promoting more content. Obviously, I'm getting a lot of traction on this. I really appreciate you guys showing up. So I really do. It's just me talking into a microphone, you know. Oh, and yeah, subscribe on Twitch too. I really appreciate that. But definitely check out my YouTube channel that I linked in the chat, and subscribe there as well. You know, every like and follow and subscribe helps me build social rank, which helps the network, as long as I'm not too much of a douche nozzle. You know, I have a tendency to get a little out of hand sometimes. I know it. I enjoy it. And it would, yeah, as long as I keep somewhat reasonable, it's good for the network to have people talking about the network. Really, true believers, people who understand it. So, help me out. Help you. Help me. Help you. Obviously, I'm an Avalanche maximalist, but tomorrow, Thursdays, I talk free for all. So we can talk about literally anything and everything. I can learn live on the air with you. I can help explain things that you have questions about. I read over a white paper, and y'all can yell at me if I don't get something correct. I'm fine with it. I'm not that guy who's going to put my ego into that. So, you know, definitely watch the stream tomorrow. So I want to go over Avalanche consensus for a little bit. We're already almost half hour into the stream, and I haven't gone over that. I did promise I would start that. So, yeah, let's start with kind of, I don't know. There's various degrees of people on this stream, and I don't know who's watching. And I don't want to like be too slow for the people who are here for the hard stuff. But I don't want to be too fast for the people who are here from day one, ground zero. So I'm going to start with a very simple question and work my way out from there, and then go over exactly what's in this doc that Dan Lane wrote. And that question is, what does it mean to come to consensus? So it's pretty straightforward in your head when you really think about it, what consensus actually means. We do it every time we vote in an election system, right? Every registered voter is voting to directly into a machine, which then tallies those votes, and the majority wins. That's a majority win vote. Over 50% wins, right? And that's what consensus means, is that we all come to an agreement on what the majority believes. But it gets a little more difficult when you have multiple colors. Let's just call them colors. Multiple things you're voting on. Each thing. Red, green, blue. Now you're voting on 3 things. Well, that becomes a little more difficult. Now add purple and yellow. That becomes even more difficult, right? A consensus protocol, a generalized one, can take every color, decide what the majority of the network prefers. So I think this idea of yes or no is very easy for people to grok. Red or gold, blue or gold or whatever. Is the network all blue, or is the network all gold? Right? Is it dressed black and blue, or is it dressed white and gold? What does everybody prefer? Believe. And that's easy with binary stuff. But when it comes to different colors of things, it's really harder to generalize and say that this actually will come to consensus. And that's the interesting thing about the Avalanche protocol, is it will take multiple inputs and vote on them. and come to consensus on which one of those inputs the entire network prefers. So that concept of preference over yes or no, yes or no is a type of preference, but that concept of preference is really important to understand. That you don't always have to binary agree with people, but you all do have to come to consensus on what path you're going to take going forward. And for that, you need to check off your preference, not what you believe. Obviously, as long as it doesn't conflict with the truth. So that's what consensus protocols basically are, is a network which can, a protocol on a network which can actually come to a decision on what the whole network's preferred outcome will be. So I really like what Dan's done here in the beginning. He's got this very clear, like, how do I start with an intuition about consensus protocols, right? And he does this very exactly what I just said. Suppose there's a binary choice between pizza and barbecue. Some people might initially prefer pizzas while others prefer barbecue. Everyone's goal is to achieve consensus. Okay? So then he extends this further, and he goes, what is the actual intuition behind Avalanche? And I love this as well. It just extends very well. Everybody asks a random subset of people. So let's just say you have a group of 1,000 people, and you want to ask a random sampling of those people. Let's say 10, 20, whatever. What do you prefer, pizza or barbecue? You get that back, and based off that sample, you could kind of get a feel for how the other people might feel, right? Now, it's not enough to just do that once, right? If you just ask 10 people once, you don't really have a good sample of what's going on in the whole network, right? You don't know if they're picking pizza or barbecue or tacos, right? But you could personally take that information and go, okay, well, because I want to be in consensus with everybody else, I'm okay with taking that information and updating my personal preference. So when I went into this, I really preferred tacos, but everybody else came back with barbecue. Okay, cool. So, let's just say 6 out of 10 came back with barbecue. Cool. Well, nobody said tacos. I'm just going to go ahead and update my preference. I'm going to prefer barbecue just to be on board with everybody else because I'm a nice guy. Cool. So you update your preference. But obviously that's not enough. So what Avalanche does is it has a formula that the whole network executes to independently measure the rest of the network. So a node on the network literally just goes out and says, I'm trying to figure out what the rest of the network actually believes. So it'll ask the whole network, hey, do you prefer pizza, barbecue, tacos? What do you prefer? What is your preference? And they'll come back with an answer. And you go, okay, cool. I'm going to update my preference based off that. But then it has to do that a certain number of times, right? And so that's where these parameters come in Avalanche. It's actually the way you can adjust the protocol to determine exactly how many times you need to ask this question to get to an answer, right? So with Avalanche, there's 4 main parameters you need to think of. There's N, which is the number of nodes on the network. Right now, let's see how many nodes we actually have on the network. We have we crossed 1,000 yet? I feel like I would have heard that. Why don't I just use these? Oh, there it is. 980. So let's just say there's 980 nodes on the network. Okay. Voting nodes on the network. And that's your N. That's the number of nodes you have. And then you have K, which is the sample size, which is how many people you're going to ask every time you have a question. Hey, pizza or barbecue? How many people are you going to ask the network each time you want to ask the network a question? I'm going to randomly ask 20 people. Okay, cool. Then your K is 20. Quorum size is the number of people that need to respond positively for you to update your preference. So you can say, well, if over half of the network says that they prefer pizza, barbecue, or tacos or whatever, then I'm going to update my preference because over the half of my samples, so over the half of the 20 that I sampled, let's just say 11 of them responded to pizza. Okay, so my barbecue now switches to pizza, or my preference changes to pizza. Okay, cool. So That's the quorum size. Now, I think in a 60% safe network, quorum size is like 0.8 with 20 sample. So I think that's right. So you would need, I think it's 14. No. Why my brain no do? 16. So maybe it's like 14. So 14 is what we actually have. So I think it's a little lower. But the point is, you would need the quorum size is basically what percentage of every sample I need to get back a positive answer to actually feel confident that that preference has changed, right? And the decision threshold is the number of, which is beta. It's the number of times you get the same answer back before you just really feel like the decision's good. It's locked in. You know what I mean? It's kind of solid. So we're doing this for a number of rounds. Basically, I'm asking random 20 people out of a network of 1,000 or 10,000 or 1,000,000, whatever. Hey, what do you prefer, pizza or barbecue? And the network comes back with an answer. And if that network responds with the answer pizza over, let's just say alpha is 0.8, that means 80% of them, then I go, okay, I'm going to update my preference. Cool. But if they don't, I just kind of keep my preference there and then move on to the next voting round. And so we keep doing this until the network comes eventually to a single decision. You just revote. And what they found in the Avalanche paper, what they could actually prove, is that the network always comes to a decision this way. See, the big thing that worries people is there going to be a partition? Like, is half of this network going to be blue and the other half going to be orange at the end of this cycle? Okay, I messed up coloring that, but you get the idea. Is half going to be blue, or is half going to be like orange at the end of the cycle? Is it going to partition? Are we going to have split decisions? Is there going to be a island of people? So like, let's say I got one little guy there, or maybe like this right here. Is this island going to be completely cut off from everybody else and believe something different? And the answer is no. That's what the Avalanche white paper proves, is that there will never be that there will never be nodes which are just kind of like not coming to consensus with the rest of the network. So that's an algorithm in a nutshell. Okay, you literally just go out, hey, give me 20 people out of the whole sample set, the whole validator set, and I'm going to ask them what they prefer, and they're going to give me their response. And if it's over alpha, I'm going to update my preference. And I'm going to do this until I get the same decision beta times. So let's say beta is like 30. Okay, I got to get 30 responses back. That's a lot. But like, that's basically the number of consecutive, as Dan called it, consecutive successes that you need to get before you realize that the whole network's correct. And the weird thing, it seems so simple. It seems like basically a stats move, like random sampling stats, right? Well, it is. The funny thing I learned about consensus protocols is it's all statistics. It's literally stats math. I have not seen anything that did not boil down to stats math. So, yeah, it's not surprising that this actually turns into stats math. Yeah, that's the thing. The initial condition doesn't matter. So Senry477 asks, does the initial condition matter? As in, say we start off with 51% pizza and 59% burger. Does the white paper prove that the consensus will be pizza at the end, or does it prove the consensus will be reached? You're guessing the second. Yeah, consensus will be reached. There will be no situation where consensus will not come to the conclusion of the majority. It will always come to the correct answer. Now, there's some caveats to that. You need correct parameterization on every node in the network. Meaning, not every node, but like, you need correct parameterization for the nodes in the network. Meaning that if some node is 51%, but one of the nodes, let's just say there's 100 nodes, and 51 of them, but that one there's one pizza node that's like super misconfigured, like really low acceptance, and it happens to flip its vote in the middle of it, it will not come to the pizza vote. It will not. It'll come to the burger vote. But like, you can't really help that in a decentralized network. You can't really do much to prevent that kind of stuff. But as long as everybody's kind of reasonably configured, the whole network will come to the same decision that is based off of like the initials. It'll come to the same preference, right? And that's incredible. That's really hard to simulate too. I know that I think Sengren is the one doing a lot of simulation work. That's really hard to be comprehensive and simulate in that in every way. So the only way you can kind of prove that, is through very advanced math. I believe that Markov chains got involved. I don't know the math behind it. That's Kevin Seknicki's field. Kevin Seknicki is a math whiz, and a computer scientist. That's not what I do. What I do is I go, okay, sir, you are correct. That looks you say it's reasonable to me. He wound up proving this stuff worked on advanced simulators inside of Cornell with a supercomputer. And he said he worked on it for like 2 months because he didn't believe that his math was correct, and it was blowing his mind. And he could not find a single scenario outside of the expected where things would not come to a general consensus across the whole network. So, it almost seems like this shouldn't work. It's so simple, but it does. And that's what's kind of incredible about this, is that it's not the complicated algorithm that Bitcoin is, because Bitcoin relies on strong mechanism design. That's what I call it, at least. It has a probabilistic consensus protocol. Okay, that's liveness over safety, because it uses mechanism design to actually achieve that sort of long-term safety. But there's a long time where that you don't know if your transaction is actually going to make it into the network, because it might be live, but it's not safe, and there's nothing that guarantees it'll always be in the network. To a reasonable doubt, like to a point, it just becomes unreasonable to think that your transaction is going to be reversed. But it's still kind of possible, I guess. So that's what it is. It's a probabilistic protocol, Bitcoin. You build more confidence with each block that's added to the chain. It's called heaviest chain consensus. The heavier the chain is, the more you believe that canonical chain is correct. And if that canonical chain contains your transaction, then the more you're also convinced that your transaction is correct. So that's Bitcoin. It's a probabilistic protocol. Well, this is a probabilistic protocol as well, except it's actually not necessarily. If you set k equal to n, this becomes a classical protocol. Now, classical protocols are probability equals 1. That means 100% of the time you're guaranteed to get an answer that is absolutely, without doubt, correct, right? But Bitcoin is a probability equals 1 minus epsilon, little tiny bit of error. There's a little bit of error left in how it works. Like you think, you are almost certain that your transaction will never be reverted on a canonical chain after a certain point. But it's not guaranteed, because there's always that chance that somebody can make a heavier chain. That's unlikely, like super unlikely, like ridiculously unlikely after a certain point. Like after 6 confirmations, people are pretty confident that their transactions got in, which is why you have to wait 60 minutes on an exchange for your transactions to go through, because block times are 10 minutes. You need six blocks to make it heavy enough to believe that your transactions got through. It's probabilistic, though. You don't know that for certain. You'll never know with 100% certainty. As you add more blocks, that error, that little epsilon, gets a little tinier each time. Little tinier. Whereas when you have like a classical protocol, just Paxos, you're guaranteed 100% of the time that as long as your assumptions are true, your safety assumptions, that the protocol has come to a decision, the same decision on all nodes, and it is finalized and completely locked in. Okay. Well, Avalanche is also related to the classical consensus protocol, insofar as if you set your k, your sample size, equal to n, your number of nodes on the network, it will become a classical p equals 1 protocol. It is a classical p equals 1 protocol at that point. You will always be guaranteed to get the answer. Okay, but that's not really reasonable or practical, because the number of messages that goes up, now you have to poll every single person. Instead of polling like 20 people out of 1,000, you're polling 1,000 people out of 1,000 each round. it literally becomes an n squared scaling problem, which is the problem with classical protocols, is that they don't scale. So you don't want to do that. What instead it does is it does a subsampling, which means you keep a consistent, constant number of messages per round until you get beta successes, consecutive successes, and then you can kind of like bail out. All right. Sorry, I didn't get that. So it comes to consensus of what the majority nodes thought as a start, or is it just consensus reached? It doesn't matter. If only 1% of the nodes were pizza, the final consensus can still be pizza. Sorry, I didn't get that. So it comes to consensus on what the majority nodes thought at the start, and then a consensus reached doesn't matter. If only 1% of the nodes were pizza, the final consensus can still be. If 1% of the nodes are pizza, you will not get pizza. If you do get pizza, that is more interesting than if you don't. Does that make sense? Like literally, if 1% of the nodes are pizza and the rest of the network is hamburgers, and the rest of the network decides to agree on pizza, you have just done the most unlikely. It is more likely that all the air in the room that you are in right now jumps to the other side and you suffocate to death than it is that happens. And this is independent of network size. Okay? So it works with 100 nodes, it works with 1,000 nodes, it works with 10,000 nodes. It actually probably might become, actually I think it is independent of network size. So it doesn't, it's so freaking unlikely that if that happens to happen, we'll study that for the next 2 centuries. Like, we'll go, what the heck? Like, we are going to be so interested in that event, right? And the thing about Bitcoin is that it kind of exposed the world to the idea that was acceptable parameters. So prior to Bitcoin, nobody thought that anybody would accept that level, like any error in their consensus. They just wouldn't accept it. Oh, no, it's probabilistic. I won't take it. But then Bitcoin comes along and they're like, actually, if you're trying to build a global network, then there is a certain level of error that's acceptable. I would say that if 1% of your nodes were pizza and the final consensus came out to pizza, it is actually more likely that let's just say 20%, 30% of the nodes immediately shut down. It's actually way more likely that 30% of the nodes in your network will shut down, that you will have a liveness failure due to massive network outages, than you ever would have a safety failure for 1% of the network being pizza and the rest being hamburgers. So yeah, it's like super ridiculously unlikely. Like Tyler just said, tcrypt 25519. That's Tyler. He said it's the same probability that the Bitcoin block will have a hash collision, and we're willing to accept that problem. We're really willing to accept that level of ridiculous not likelihood, right? So if we're willing to accept that with Bitcoin, we're definitely willing to accept that with Avalanche, and that's why we can do this in prior models we couldn't. So long story short is that the way this protocol works is really straightforward with regard to that. But then the question is, like, how do you do actually that voting? Obviously, there's a lot of different transactions kind of coming in. Well, that is true. Senri points out that, Senri477 points out, the gist of my question is what the paper proves. Even if the whole network does decide on pizza, at least the whole network came to a consensus. That is a very, very correct point. It still comes to a decision. It might not be the preferred one, but it's at least a decision. And it's, by the way, not a invalid decision. You're not making invalid state transitions. You're not double spending here. You're coming to a decision, the network just agrees on that decision, right? So, yeah, that's not the end of the world, even. The thing is, you wouldn't know that happened unless you had a perfect view of the entire system. Like, you wouldn't even know that happened. You don't have a perfect view of the system. That's the point of consensus. If you had a perfect view of the whole system, you wouldn't need a consensus protocol, right? You wouldn't need a consensus protocol. You would just go, okay, well, the whole system says this. The point of a consensus protocol is that each individual node does not know the state of the whole system. So it needs to actually ask questions to come to a decision, and that he has to be assured that at the end of this process, whatever decision he's come to is the same decision that everybody else came to. It doesn't necessarily mean that in day one, the decision process is is the same as the decision process at the end, although preferably we want something that's pretty close. You don't want to pick something that's too far off the day one decision. Like I said, there could be misconfigured nodes out there. You don't know any reason why, what preferences, what leads to an ultimate decision in the network. But it doesn't matter. As long as in the end, everybody comes to the same consensus decision, then we're good. Okay, so the next question that a lot of people bring up is they're like, oh, Avalanche is a DAG protocol. First off, DAG is just a data structure. So Bitcoin is a blockchain by necessity. It has to be a blockchain. Ethereum, also, Nakamoto, has to be a blockchain, but also smart contracts to this point have required totally ordered blocks. But you don't have to do that. And if you're looking for high throughput, you want a lot of things going at the same time, right? You don't want to be like one after the other, after the other, after the other. That slows things down inherently. And we've seen this before. We have arguments about block sizes, right? Now, how big should a block be? What should our block time be? What's the difficulty? And that's deciding how fast these blocks are added to the network. Wouldn't it be much better if you could just add things as they come? And that's why DAGs are actually a really good option for high throughput transactions. Now, you've seen people do this like IOTA and stuff where they took the word DAG and they just ran with it and said their consensus protocol is DAG. DAGs have nothing to do with consensus protocols. It's just a way of storing data. It's just a way of managing the data and the preferences of that data so that you can have a lot of decisions being done simultaneously rather than having them be one after the other for literally everything. So Avalanche uses a DAG to do that on the X chain, but obviously we went with a snowman model on the P chain and on the C chain, which has to do it because of Ethereum requires it, But so C chain and P chain are both normal linear blockchains, but the X chain is high throughput. That's what makes it amazing. Is that one of the ways it does that is it manages all of its transaction history in a DAG, and all a DAG is instead of being fully ordered, yes, it's being totally recorded. You can totally watch it later on this or on my YouTube. Salim Avalanche. So yeah, you could totally watch this later if you want to catch up. But a DAG is partially ordered. What does that mean? It's like, look, it's like D might have come after B, but it's still a child of A. So A is the parent, and D is a descendant of that parent. E is a descendant of C, which is also a descendant of A. So it's partially ordered, but E came in way after D. So if you take this as sort of like a timeline, I don't know if you guys can see you can see my mouse. A timeline, A came first, then B and C came about the same time, and then D came in after that. But D is also a child of a descendant of A. It's also a descendant of C and B. So like that's how these weird more complicated structures could come in. But it also means that D can come in and not wait for all the other transactions to sort of finalize in a linear block. Does that make sense? So you can make decisions on D while you're also making decisions on C and B. And if B fails, then D also has to fail. See what I mean? I don't know what the IOTA dudes are doing. I'll be straight with you. They haven't delivered anything that works, so whatever. Look, I mean, we pumped this network out in 15 months, really, maybe 2 years. Yeah, if you count when Steven started, it's about 2 years. Steven worked alone for a little while, Steven Butoff, trying to build the early stage version of the Go client. But, I mean, it's not, it took us 15 months. IOTA's been working at it forever. They've had so many failures. They added a coordinator because their stuff just doesn't work. IOTA doesn't count. IOTA doesn't work. Period. So the DAG part has nothing to do with it. DAG is just a data structure. Anybody who says their consensus is DAG, they're idiots. The consensus is Avalanche. The consensus is Snowball. Okay? But the DAG is used to manage the X chain, and Snowman blockchain is used to manage the P chain and the C chain because it's totally ordered. That's all. So it's interesting, though, when you just want to know what we mean by DAG, the X chain is high throughput because it can handle multiple things at once. So let's see how this... Dan has really done a great job of illustrating this. You've got a transaction, and you want to talk about your preferences on that transaction. Here's the parent, the grandparent, I guess you could call it, transaction V. Here's two descendants of V, W and X, and then they both are dependent on new transaction Y is coming in, and it's dependent on X and W. So it has this like base level confidence that gets updated. I'm going to say right now that XChain and IOTA are not similar ideas. Simply because IOTA believes that the way that IOTA structured things is that you have to constantly be adding new transactions to confirm the previous transactions, and you should not need that. In other words, they try to use heaviest chain principles on a DAG, and it fails because you have to have a volume which exceeds previous volume. You have to constantly having new transactions dumped into the network. Otherwise, you come to a halt. And there's no single decision-making process on a single transaction, meaning that you can't stop having transactions flow through the network in the tangle, or else it just won't work. So I would say that IOTA is just nonsense. It's not even related or similar ideas. Just because it has a DAG does not mean it's similar. The voting protocol that Avalanche has just manages its data in a DAG, but it's still a voting protocol. It's a different classification of protocol than IOTA. Yeah, I would not say that they're the same or even related. I would say that IOTA is closer because it uses this whole weights concept. Is way closer to Nakamoto than Avalanche is to Nakamoto. Yeah, XChain is just a VM. Yeah, DAG is just a VM. It's just an implementation, a way to vote on things, and the actual consensus protocol itself is totally different. Just because they share a DAG doesn't mean that it's fine. And even then, like, by the way, DAGs are used in the voting protocol, which is used in the consensus engine on Avalanche, right? So this stuff doesn't even actually exist in the XChain itself. I believe the only thing that's in the XChain itself is just the UTXO set that's being decided on and the rules around that. But the actual consensus engine is what's dealing with the DAG stuff. And that means that the DAG stuff is in the Avalanche and Snowstorm, actually, consensus stuff. And that's just used to come to decisions in memory. And then once those decisions are accepted or rejected and committed, finalized, it goes into the XChain on the actual so like the Avalanche engine is totally different than the XChain. XChain is just UTXO manager, basically, from what I can tell. It's pretty much it. Like, that's good. That's what VMs are supposed to be. Like, you shouldn't have this, like, you should have this partitioning here where the VM is just managing the data, the state, and the consensus is something totally separate. That can be totally pulled in separately. And that's a brilliant design decision that only Avalanche could really make, from what I can tell. I mean, I guess, classical-based things can do it too, like Cosmos. But they're classical, so they're stuck with the number of validators they got. Anyway, long and short of it is the DAG stuff is all in the consensus engine. So basically, Transaction V has descendants, and Transaction V has this concept of confidence in consecutive successes. And the idea of a confidence is how confident am I that this transaction is correct? And the more transactions you build on top of that transaction, it kind of increases that confidence in that transaction. But it's not necessary to sort of to lock something in, meaning that consecutive successes also play a role in this equation. And we talked about that with beta. The beta variable, the consecutive successes. The more times I ask the network, hey, what's your preferred transaction? We'll call it transaction for now. What's your preferred transaction? What's your preferred transaction? The more times it comes back with an answer. The number of times it comes back with consecutive answers that are the same, that increases the number of consecutive successes on the actual transaction itself. And that, of course, means that all the parents of that transaction also get that number of consecutive successes improved upon, because by the transitive property, if you vote that transaction Y is correct, you must also agree that transaction W is correct, and you also must agree that transaction X is correct, which then also means you must vote for transaction V. So all these votes sort of like play on each other. But like that's pretty much it. And then the confidence is, basically how confident are you that this transaction is correct based off the confidence level of the parent above it. So if the children below it. So if transaction V will be the sum of all the confidences of its children. So because this has a confidence of 1, okay, starts off with that. But then W also has a confidence, and then X has a confidence. I don't think I'm saying that right, because confidence is not the sum of the vertex chits plus the sum of the descendants chits. Okay, so I don't think that is correct. Either way, the idea is basically, is that correct? So why would that be 4? Confidence is sum of the descendants chits plus my chit value. So, but this has 4. Is it direct descendants? Because this should be 5. Whatever, I'll ask later. I think that should be 5. So anyway, basically, confidence is another thing you can do to improve the belief that this transaction is final. And when you get past a certain threshold of confidence, you can go basically, yeah, this transaction is final. Like this is good. We got this. This is correct. So anyway, that is basically, in a nutshell, what Avalanche does. And the thing is, like, each node on the network is independently coming to the decision process that it needs to know what the rest of the network looks like, to get an idea of what the actual state of the entire network is and what his state should be. So that's also a really cool part of it is there's no need for a leader, although I don't have a problem with leaders. I think leadership protocols are a great optimization. But you still need to do voting and stuff like that. But like in terms of like coordinators, like there's no coordinator. There's no like set of preferred nodes. There's no cabal running this like in classical protocols. Every node is independently coming to the decision on what it prefers. And that independent decision is what drives the whole network to come to the same decision. That's the weirdest part about it. That's the counterintuitive part. Is that my node is not technically logically connected to any other node in any real way, other than I know they exist and I ask them questions. But based off the questions that I ask them, I can tell you what they actually believe. Not just what they believe, but what every node in the network really believes. That's how I get a synchronized state. It's really cool. Really cool idea. Like, it's really cool. It works out. It's fantastic. Let me see. Salim Avalanche asked a question real quick. Can the exchange support smart contracts in the future? Is this possible? Stephen Butoff thinks it's possible. I'm learned not to question him too hard. I have never seen a partially ordered smart contract system. But I also don't believe that we need to worry about partial ordering on the exchange to do smart contracts. Meaning that you can just wait until a certain confidence level before a smart contract is truly executed. This will make more sense in the vertices part coming down the road. Like, I'm not convinced you need fully ordering in order to do actions on a UTXO. You can actually just do a UTXO operation or UTXO function or UTXO action, and they could vote on it like they would any other transaction preference. Now, whether or not that has lasting consequences, I'm not sure. So, lasting consequence is not the right word. It has immediate consequences. That's where I'm unclear. Would voting on a logical operation change the way the network can be gamed in consensus? Meaning that, can I look at a smart contract being run and go, okay, well then I'm going to not prefer that smart contract, I'm going to prefer this one just because? Will that make things different? Will that make things more gameable? I actually don't know. Especially when you get into interactions and smart contracts, which call smart contracts, I'm not sure how that really plays out. So if I have smart contract A and it calls smart contract B, do I vote on both A and B as one operation? I would assume so. But what if I don't know that B is going to be executed until I execute A? So smart contract A has a function in it, and in that smart contract is a if statement. And if I execute A, then I also must execute B in that if statement. But if that if statement fails, then I don't execute B at all. Instead, I execute C. How would I know that until I actually execute the smart contract? So do I need to execute all smart contracts in every single, like all possible branches of a smart contract in every single execution in order to do consensus on that smart contract with a partially ordered chain? It might be the case that actually makes it a partially ordered DAG. It might be the case that's it, and I don't know for certain, but it might be a problem. So I won't answer if it's possible to support smart contracts on the X chain or not. I don't know, but to me, my instinct says there's something you can do that works. Like, it doesn't sound impossible. It doesn't sound like something that you can't possibly ever do. And one of the things that Stephen Butoff mentioned is the idea of smart contracts that can be consumed like UTXOs. And so until they're consumed, they must be, they exist. And then the idea is to prevent a double spend on the consumption of the UTXO. But the problem then still becomes, if there's an if statement in the middle of that smart contract UTXO, what are you consuming? Like, are you consuming another smart contract, or can multiple people consume the same smart contract at once? Like, there's no reason why I shouldn't be able to also consume a smart contract. Well, I guess one of the operations I could do is produce a smart contract, then I consume that smart contract, which could maybe prevent some of this stuff. So I could actually literally say, I am going to produce smart contract A and smart contract B, and I prefer that you execute A and then execute B and consume both of them in that process. That might be a way to handle that, to prevent a double spendy situation in DAGs. But I'm just spitballing here. Like, these are just things that I don't know will work or not. And I'm, again, not the deepest engineer possible. It's just the way that I think out loud. It's probably nonsense. It's probably all nonsense. I have no idea. But it seems to me like being able to produce a UTXO that has a side operation of like consuming like smart contracty UTXOs would actually probably work in a partial ordered environment, which I think Steven had mentioned something similar to that to me before, so maybe that's why my brain's going there. But I don't know. I don't know if it'll work. I don't know if you can do smart exchange smart contracts in the future. I hope so. I would love to see something more like the X-Chain support automated logic, because it's clearly shown a need. Senri477 says, honestly, it seems like this could have applications relations to other areas, e.g. swarm intelligence. Dude, I have thought the exact same thing. I see all these like drones going around and like, flying over cities and stuff and spelling things out, and like they don't know where they are and they don't know if they can. They're not coming to a decision. It's all pre-programmed for them. Everything's they're running through a coordinator. But what if you could remove that coordinator and tell them to just do stuff? And they all come to a decision on what the next thing they're going to do is, and then they all come to a decision on where they are with relation to each other, and then they all come to a decision on how they're going to fly around, blah, 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 and where they are. I mean, that's cool. They can be a completely autonomous decision-making process, a DAO in the sky. How freaking cool would that be? Let's go even like more realistic, though. Let's just say you're having swarm, little tiny consensus, localized consensus networks. So you have a shipping crate, and there are a ton of packages in there, and they all need to agree on what the state of the shipping crate is in order for their contents to actually be assured. So like, if one particular sensor goes out, then they need to be able to say that this sensor is uncertain of its state, and so it cannot pass import inspection when it goes into another country because it has its black hole in knowledge. It basically was rogue. Okay, what if you could do something like that? Sensor, inside of shipping, be able to optimize the import-exportation process of things through just this localized consensus mechanism. What if you wanted to have packages which were just aware of each other, like, and their needs? So a shipping guy comes in and he tries to put something on top of something else, and like for instance meat on top of vegetables, and like there's contamination issues with that, and it sends an alert that you're not allowed to put meat on top of vegetables. Okay, there's a code violation, right? And it could maybe pass, I don't know, salmonella, listeria. I don't know how things are made. I don't know much about biology and stuff like that, but like what if it could actually alert people before it even hit the shelves, just because the crate that it's in has a little autonomous protocol, which then joins a network that's localized consensus and comes to agreement on what's in the state of the system, and then acts on that state. Now, I guess you could use a coordinator for all of this stuff, but you'd need a lot of coordinators, and an open protocol would be a much better, cleaner way of doing this. And much more programmable, put it to you that way. And then all you need to do is have the boxes. You need boxes which can do that stuff. Anyway, come from a more AI perspective. Yeah, that makes sense. I don't know. I'm just spitballing. That might be nonsense. It might not work, but it's just a thought. Okay. Let's see. Where am I? We got the confidence. One thing that they want to point out that's really important is that the DAGs don't just accept... Okay, yeah. Let's talk about conflicting sets. So, what does it mean to conflict in a consensus protocol? Like in Bitcoin, it's called a double spend, but basically it means you're trying to spend the same UTXO. Let's just say you're in a UTXO model. You're trying to spend the same UTXO. In Ethereum, you're trying to spend on the same nonce, or a nonce that is not greater than or equal to the current nonce for an address. So I have UTXO 1, 2, 3, 4, 5, and transaction Y spends 0.1 from that. Transaction B spends 1.0 from that. Even if it has a balance of 10, it can support both transactions. If it's trying to spend the same UTXO instead of the output of that UTXO, it's called conflicting. It's called conflicting transaction, because you don't know which. They're both valid. They're both valid state transitions. They're both sending a valid amount. They're both valid signatures. But one says 0.1 and the other one says 1.0 of Ox is being spent. And even if the result is, there's a remainder and they're still going to have a zero sum, you don't know which one's actually supposed to be spent, because you're trying to spend the same UTXO. When really what you want to do is you would spend one UTXO and then you would spend the output of that UTXO if you wanted to do both transactions. But if you try and spend the same UTXO at the same time, it's called a conflicting transaction. And when you get those, you got a conflicting transaction set. Okay? And the conflicting set is something that needs to be resolved in a network. You don't want two transactions that spend the same UTXO to both be approved at the same time. That is literally the definition of a double spend. So that's what this preference thing is about. When I say the network decides on pizza, barbecue, or tacos, I'm talking about everybody trying to spend the same dinner UTXO. You know what I mean? Like they're trying to make the decision on the same, how do we handle the same operation, which is what do we eat for dinner, right? And one person might want to, it's basically like a color. So like the 0.1 transaction is the color barbecue, and the 1.0 transaction is the color pizza, okay, or hamburgers or whatever. But they're both trying to spend the same operation, which is the dinner operation, right? The dinner UTXO, the dinner output. So the conflicting set, the colors that we're talking about, is just like what does somebody see that is trying to do the same thing on the same thing, on the same, the same data. And unfortunately, in reality, we almost never see this. Like, this rarely comes up. It happens It's the edge case that we worry about, but it doesn't happen as frequently as valid, virtuous, non-conflicting transactions. If something's non-conflicting, you could pretty much start accepting that right away. Like the whole network will just come to a decision on that very quickly. And almost always it does. The problem comes in when there is a conflicting transaction, right? And that's when the network needs to sort of come to a longer decision, or more of a decision-making process. The cool thing about Avalanche is it's not longer. It actually takes about the same amount of time to come to a decision on the conflicting transactions as it would on a normal one. Now, that's assuming a non-complex conflicting transaction set. But eventually it will cascade into a decision-making process, and it won't take very long before the network sort of just like comes to a decision on that conflicting set. But in the case that it's a virtuous transaction, it takes a constant amount of time to come to a decision on the network. Because everybody just prefers the same transaction. Oh yeah, you're spending that output? Okay, cool. Anybody got a problem with that? No? Okay. Go ahead and spend it. Never a problem. It's very rare that you see these conflicting transactions. It's basically preventing people from screwing themselves mostly. Like it's a problem with smart contract development with Ethereum. When I did a lot of that, nonce conflicts were common in my code because I would accidentally not update the nonce when I'm trying to get multiple transactions into the same block, right? And so with Ethereum, every is an account model, so every address has a nonce, and that nonce must be strictly increasing in the Ethereum blockchain. So if I'm address dead beef, and I send my first transaction, my nonce goes to 1. Now I have to send another transaction, it'll go to 2. If I try and send two threes on my next round, so I try to send a transaction A with nonce 3 and transaction B with nonce 3, even if they're both perfectly valid and that they spend my balance, they don't go over my balance amount, it's basically a conflicting transaction that the nonce didn't increase, and so it doesn't know how to order it. And it doesn't know which one to execute first. And so same thing with UTXOs. If UTXO ID dead beef is being signed for and spent, and it produces another output and for the remainder, and then same UTXO dead beef is being spent by another transaction, that conflicts. It's basically the same thing as the way the nonce works, except in UTXO model, when you spend a UTXO, that UTXO can be deleted. It can be pruned because you've just spent it. It produces a new output, but that output might actually consolidate. It can actually come together and be consolidated into less data. Whereas with the account model, you're always getting a strictly increasing amount of data in the state. Anyway, where was I going with this? That's what a conflicting transaction set is. And so most of the time in the Avalanche consensus protocol, you're not trying to resolve things as much as you're trying to resolve problems with things that you don't know. The network will come to consensus on non-conflicting virtuous transactions very quickly. It's the conflicting stuff that really needs to be looked at. Anyway, one other thing I think is important to point out is that there's this concept of vertices. So in Bitcoin, there is the concept of a block. Well, in the Avalanche protocol, not the Snowman protocol, the Avalanche protocol, there's a concept of vertice. And it's literally just a block. But instead of having it be linear, it's just exactly what you saw above here with transactions. But instead of this being one transaction, it's a batch of transactions. And so you can make the same decision-making process that you see with just a single transaction with a batch of transactions, because all they're voting on is preferred vertices. If the vertice is preferred, then the network votes that it's a preferred vertice the same way it would if it was a preferred transaction in the simple case. So this is how you can kind of optimize over Avalanche and not have all the decisions being made for every single transaction. You can actually just batch blocks of transactions and publish them and basically say these are the transactions we're voting on. And that's a beautiful thing. That's a beautiful optimization. It really makes things go fast. It's great. So yeah, that's another thing you should point out. finality in, I've mentioned this before, finality in a probabilistic consensus protocol like blockchain that uses heaviest chain. It takes a certain number of confirmations before you feel confident about it, but in Avalanche, it might have this confidence level, but it comes to once a transaction is finalized, it is forever finalized. There's no need to keep a history. There's no heaviest chain. There's no chance of a canonical chain change. Everything is just finalized. Everybody agrees and it's final. So you don't need the state history from back to Genesis to actually feel confident in the finality of a particular transaction getting into blocks. So that's great. And so yeah, that's pretty much what Avalanche does and what it is. I've talked about the concept of transitive voting. Let's see. This is an important part. So when you build a transaction, you're not the node is not directly voting on that transaction. It's voting on the batch of transactions of vertices, right? So from a tooling perspective, Avalanche Go is a vertice building tool, as Dan states here. And it's also a transaction building tool, meaning there's APIs on it which can actually build specific transactions, do specific things. And then you have another tool, Avalanche.js, which actually does some of the transaction building as well. So transactions can be built independent of the vertices, but you will need a node to actually do the vertice building itself. So that's kind of just a little caveat to make, a little thing to point out. Yeah, otherwise, this is pretty much the explanation of how Avalanche builds and decides on transactions. It's a really good consensus article on consensus. Dan did a great job going through this and putting stuff out. It's really great for having people just understand that sort of high level of how things kind of work. So yeah, I think it helps you understand some of the API parameters that you're actually putting into your node. So yeah, and with that, I'm getting a little warm. I have to open up a door real quick, and I will be right back. Hold on one second. Okay, let's see. Sorry about that. Yeah, open a door. Take a leak. I didn't want to be too rude. I've been doing this like the past 3 streams. Maybe I should stop drinking coffee like all day. Why you gotta call me out like that, chill bro? Not a very chill move for a chill bro. Whatever, I'm a hypocrite. I don't care. Yeah, I should lose weight, he says as he plays video games. I got a weird sense of discipline. When I'm in 100%. But when I'm not into it, it doesn't happen. Like, I like my coffee drug. It's delicious. Anywho. All right. What do you guys want to learn about? Is there anything you guys are specifically interested in? Like, I'm really glad I had the opportunity to go over, like, the consensus protocol. And by the way, I have the ability to pull you guys in for a phone call. If anybody wants to hop on the phone, we can do that. I can also invite you to be on the stream. I don't mind inviting guests. But, you know, this is kind of a show for you guys as well. Like, if you want to know something, please feel free to ask. Okay? So if not, I'm going to go ahead and just move on and talk about staking. Because I think one of the major misconceptions, and I'm frustrated that people still have this. I'm 10 years old, too young to be on stream. Jesus, chill, bro. I don't believe you. I don't believe you at all. But anyway, so what was I gonna say? Oh, I actually got a new emote. I wonder if that like works yet. Let's see. Does that work? So it's was it Colin 68? Wait, is it really 68? That work? Let's take a look. Doesn't look like it worked. It's an emote prefix. So I don't think it works like that. I'm still all new to this stuff. But yeah, alright, well whatever. I'm gonna get some new emotes coming on this. I'm excited for that. Alright, so where was I? Yeah, let's talk about staking here, huh? What's up, Rum Bites? Sea Dog! Alright, so my big concern about the Wednesday technicals is that I will run out of material. And I can start rehashing stuff over and over again, but I'll run out of material. Plus, it's not my highest viewing show. So I might do this like a once a month thing instead. Because I feel like that's more appropriate. The speed of development and the speed of ecosystem stuff for Avalanche and the free-for-all day is like way different. So like Avalanche will come out with new stuff like monthly is a good reporting stream, you know what I mean, for technical stuff. But I do think that the ecosystem stuff for just Avalanche Tuesdays and then free-for-all Thursdays is going to be much better. And easier to keep up with. I'm going to get stressed out if I'm worried about what I'm going to talk about every Wednesday, because I will run through this material super fast. There's a lot to cover, but it's not that much, and I could fill out this course in like a month and a half. I think we'd run out of stuff. So I'm tempted to make, maybe not even bi-weekly. I really feel like a monthly like technical show is probably going to be the way I go about it. So we'll see. And then it's going to be Among Us Fridays. So I'm going to be starting to play Among Us every Friday. And then it's going to be World of Warcraft Saturdays. And then Fortnite Sundays. Screw you, Mom. I'm watching Colin on Fortnite Sundays. I'm not going to come down for family dinner. You're gonna love me anyway. And it's gonna be, what is it gonna be? We'll be on, Just Chatting Mondays, so that I can, put on a bikini and sit in a hot tub. Have you guys just bask in my glory, like the God Emperor that I am. None of that's happening. Nah, none of that's happening. You just, ooh, yeah, I do gotta lose weight. Look at those jowls. Like a turkey. Yeah, so I do think I'm gonna cut down on the technical Wednesdays, just because I have to. Like, I'm straight up gonna run out of material. There's a lot here, but like, you're gonna finish it. Like, everybody's gonna finish it really quick. So I don't think I need to do that as frequently. But I do need to do it, and I think it's important that you guys have a day when you can really just go into some of the technical stuff, I guess. How do you guys feel about that? You have any problem with that? Skeleton4 says, why is it still so challenging to get funds of Vox? Jeez, dude, that's all relationship building stuff, you know what I mean? So, I don't know the details behind that. I know it was hard to get exchanges to list us just because our, like, here's the thing you gotta realize, like, everybody to this point has pretty much been, Nakamoto chains, you know, they're totally ordered, or some chain of some sort, you know, they're totally ordered. There's block time and there's regular synchronous stuff. It's almost everything is completely, totally synchronous, right? Okay, well, we're not. And we don't have block height. We can't, like, we didn't have the concept of block height. It's not something that exists in Avalanche because the X chain was a chain. Now, one of the cool things about the C chain is it made integration easier. There was a bit of miscommunication at one point. Somebody was integrating with us, and I thought they were supposed to integrate on the X chain. I was like, oh boy. And then they were trying to do it on the C chain. I thought we weren't doing that. And yeah, I got chewed out because like I told them not to do that, but then Kevin had already told them to do that. A lot of confusion there. Startup bullshit. Well, look, C chain's easier to integrate with. Like it is. It's legitimately easier to integrate with because everybody knows Ethereum. But then there's still quirks in the C chain. There's no guaranteed block time. Like you can't use block height. You don't know how fast those blocks will be pumping out. On 1 minute they could be going the full 200 transactions per blocks per second, right? By the way, it's literally like blocks happen fast, or they could not happen, and that's the thing. Avalanche is quiescent. It's a beautiful thing about it. It doesn't do work if there's no work to be done. That's an antiquated Bitcoin-esque concept. We're going to do work even if it doesn't need to be done? That's wasteful. No. Avalanche is quiescent. If there's no work to be done, it sits in the corner and stares at the wall. That's all it does. It does nothing. If there's nobody sending transactions through this network, there will be no transactions on this network. There will be no new blocks. It is quiescent. You know, you got all these guys trying to integrate with us, and they're like, so what are your block times? We're quiescent. Okay. Well, our system needs it. I have a database, and there's a field in it, and it says block time. You gotta tell me what your block time is. I'm gonna expect that block time to be correct, or otherwise my whole system's gonna screw up. Everybody's like that, because they've all been working with nothing but Nakamoto. Now, I mean, there's other protocols I think are a little less like that, but they do stuff to fix that. Like, I mean, like, you don't have to be that way with like a classical protocol. Anything that's running classical, you don't have to have a block time. Of course, if you want to integrate, you gotta figure something out. She is going to hit 12 exabyte network size today, and there are tons of people waiting to start farming when pools are implemented. Get hard drives if you need them now. Hey man, that's good advice. What can I say? I think Chia does a thing. It's seeming to not suck. I think that's cool. Is it better than Avalanche? No, it's not better than Avalanche. Not even remotely better than Avalanche. In no way, shape, or form is Chia even close to Avalanche on performance. Like, no. I mean, it's terrible. Like, the Senri's like 477 literally lays it out. God, that's horrible is his response. His or hers, whatever. Chia's going to hit 12 exabytes. Go get your hard drives now. Better buy a hard drive. Otherwise, you're not going to get that sweet Chia. That's a terrible way to run Sybil protection. Don't do that if you don't have to. Why? Why do you need to do that? That's wasted hard drive space, dog. Like, there is no functionality coming out of that hard drive. It is proof of uselessness. That is what that is. It is freaking proof of random number uselessness. So, yeah. Skeleton, did I fully answer your question? I'm sorry. Look, it's harder for people to integrate with Avalanche just because it's so new. I don't think that's impossible. People are still integrating with us just fine. It's just not been a priority. Plus, there's all these little contractual things you got to check off. Look, we're a protocol that came out September 21st, 2020. We released our mainnet on that day, okay? There are so many applications being built on us already. It is not surprising though, to me, that people will have a harder time integrating with us than other people, considering that we're such a freaking unique paradigm. Now, I don't think that's the only reason, but it's definitely not. But like, you know, it's you know, there's you can use KuCoin, you can use, what is it, OKX, OKCoin, I can't remember. If you just want to bet on the market, you can use Voyager. It's custodial. But there's no reason why. There's reasons why it's a little more difficult, but it's not a blocker. It's gonna happen. It's in the works. I guarantee it. You name something, it's probably in the works. So I mean, we were on Binance day one. We were on Binance, just not Binance US. Look where we started. Yeah, we're on Binance. So I just hit any random somewhere. I don't know why I hit that. I just like that button. Anyway, but yeah, she is a waste. She is wasteful. Super wasteful. They call themselves green, but like, yeah, I don't know. I don't know what like. It's not free to run a data farm. Like, you got a bunch of hard drives. They need cooling too. It's not like, you know, if you're running a petabyte of data, you need a data center. That's not free. That's not green. That's not what green looks like. It's greener, but it's not green. Whatever. You need a good internet connection too. I believe you need a good internet connection for that one. I'm not certain, but I believe you do. Anyway. Nah, it's probably not as important for that one. Now I think about it. Probably no more so than Avalanche. That's probably moot. But yeah, I mean, it's not green. Like, it's like you're just less bad than Bitcoin, which is fine. Like, I love that. I think they got something there. Like, literally, I think there's probably some other tangential piece of cool research that will come out of Chia. I just don't think that the coin itself does what that, especially with, like, maybe like if this was 6 years ago, I would say that Chia would be the new hotness and the world is going to change because of Chia, because it's so much better than Avalanche. And yeah, Playa, yeah, better than GPU mining, so much better than that. Hard, like, absolutely. And there's not as much an arm race. Don't get me wrong, like, it's fantastic. But do I think that it's competing with Avalanche? No, absolutely not. Not even close. I think we use less than 1% of what Chia does on energy consumption. I would be like, this runs on a frickin' Raspberry Pi. I wouldn't recommend it, but it can. Chia doesn't run on no Raspberry Pi. It runs on, well, maybe as it could, like, the node can, but like the actual hard drives that it's using doesn't. We use less than 1% of what Chia does, which tells you exactly how greener we are than Bitcoin. And we are so green. Like, we are the greenest possible, like, protocol. I can't think of any more optimization than running on the best, being CPU bound. That's the bare minimum. You know? Yeah, I know. My buddy called from back home. Was like, hey man, what do you think about Chia? There's gonna be an arms race for Chia. That's just what's gonna happen. But it's it's still better than ASICs. It's in GPUs and stuff. So, And by the way, guys, like, here's the thing. It's like, people aren't still aware of this, and I don't know who's on this stream again. But farm on PyPlot on PC. Okay. But proof of work is not a consensus protocol. I don't think people realize that. Like, oh yeah, Snapdoodle, it is Leia Playa. Oh, wow, I forgot. I forgot your username, dude. Do you see the embarrassment on my face? I'm actually touching my face in embarrassment. Yeah, sorry, dude. Like, look. Welcome to the stream, by the way. Proof of work is not a consensus protocol. It's Sybil protection. So what is Sybil protection? This is something that I feel like so many people are not getting after all this time. It was a hard distinction for me to make. Sybil protection is literally just saying you got a ton of pseudonymous accounts. How do you know they're all operated by the same actor? And by the actor, I mean real world actor, real person, real investor, real individual, right? Okay, like, how do you know? How do you know that they are really one person? And proof of work is a way of doing that. It forces people to dump energy, real cost, into the system. And that cost can only come from an actor or multiple actors, right? And your voting power, your ability to actually influence the network, is weighted based off that cost. Well, in proof of work, it's the compute you put in to check hashes on the network, right? Okay, so you dump a bunch of GPU cycles in looking for a nonce. You discover that nonce, and now you've basically been elected as leader of the next block. You get to propose the next block. Okay, that's Nakamoto's model, and then you've got proof of space-time, which does the same freaking thing basically, but you get to propose the next block if you've discovered a random number on your hard drive. Which means that if you could fit more random numbers on your hard drive, you can actually discover more nonsense. Like, you discover a solution better than everybody else. Like, that's what proof of space-time is. It's the same thing as proof of work. It really is. It's just using the closest approximation to an answer. And if everybody agrees that your answer is closest, then you get to be the next block producer, right? That's what proof of space-time basically is. Literally is. So, it's also proof of work. That's what it is. It's literally just pre-computed proof of work. Like, that's basically it. And not only that, but wait. Then they got the concept of VDF. So, VDFs are cool. So, it's got this idea that you can actually, VDFs is a verifiable delay function, which means you can guarantee that this function will only happen at you can only do it after a certain delay. On or after that certain delay. It's a literal computation you can do that can only happen in a certain amount of time. And that delay, that minimum that's set with that VDF, basically enables people to have a clock, which makes this protocol synchronous. Mind you, Avalanche is asynchronous, which is fantastic. You want asynchronous. You do not want synchronous. Synchronous puts an artificial cap on the speed of your protocol, okay? She is synchronous by design. That's why they have VDFs. Boom, 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 right? Can only do things as fast as they can go. So it's basically pre-computed proof of work, in a way. Like, that's what proof of space-time basically is with a clock function. It's still proof of work. Avalanche instead uses the staking, proof of stake, which I can get into here in a second. I do get it. What I mean is, so to combine fast Avalanche consensus, but with proof of work, Sybil protection on a subnet, your opinion. I mean, why? Like, yes, you can. Yes, you totally can. Like, I don't see why you couldn't create a proof of work Sybil protection on a subnet. Like, all blocks to be minted. Well, you're not using Avalanche at that point. How would that look? I don't know how that would look. So you can do things with proof of work UTXOs that require proof of work to spend them. But then it's like, that doesn't work really well either. Because, yeah, you're still like, no, that doesn't work. That's stupid. I don't know why you would use proof of work on a subnet. Like, the proof of work UTXO idea is really great for rate limiting people who can randomly spend an unowned UTXO, but like I don't know why you would do that. I don't know why you would ever do that. Like, you got Avalanche, it's better. Like, you'd want to stake with your own token and use that to incentivize people to validate your subnet. That's the ideal situation on that. I don't see why you would need a subnet at all. Like, you want your validators in Avalanche to be validators in the subnet, right? Well, validators run Avalanche. That's what they do. They use Avalanche voting protocol. So why would you remove voting protocols entirely and instead go with heaviest chain? What would the civil protection be? Like, if you want to vote, you must earn a vote chit by solving a proof of work. You hash in the background to collect voting rights. Avalanche you'd still use to sync with others. So you hash in the background to collect voting rights. So you would basically mint voting tokens, right? That's what you're saying? So to get a voting token, you must solve a proof of work. And by solving that proof of work, you get that voting token, which enables you to vote. That inherently limits your entire network, right? The number of people putting power into your network is now, like, that's like literally not necessary. You've completely, like, why would you do that? That's what I don't understand. Now, you might have a valid reason. I just don't know what it is. Why would you want to add that kind of limitation to your network? Is it because you philosophically believe that dumping energy into a network is better than you don't like proof of stake? Well, don't use proof of stake. Go do your 7 transactions per second on Bitcoin. Schmuck. The like, literally, what are you doing that's better? Like, nothing improves with proof of work. Nothing. Right? The arguments are moot. Like, they're bad. So, you don't like proof of stake, but you like Avalanche. Okay, so how about this? I get it. All right, so how about this? In order to vote, for the next epoch, in order to be a voter, you have to solve a proof of work during this epoch. So I got a proof of work that I got to solve in this epoch. It's got a certain difficulty. In order for me to be a voter, I need to, in order for my voting node, I need to actually solve that proof of work. If I do not manage to solve it, I'm not allowed to vote in the next round. Okay? Okay. You can do that. So, like, let's say let's say you've got epochs in your voting, in your protocol. Okay, so let's say it lasts 6 minutes. You got a 6-minute epoch voting protocol, and you have to solve, in order to join the network as a voter, you have to solve a proof of work that requires, on average, 3.5 minutes, let's just say, to solve on an average GPU. Okay, you solve that on an average GPU, and you get your proof of work. But, like, that's not very difficult, right? Like, let's say I'm a Chinese Bitcoin miner, and I use my entire rig to solve that thing. I've got an entire rig's worth of votes, right? Or votable nodes. But I also, all those rigs have to be validators on the Avalanche network, which is proof of stake, right? See what I'm getting at? It doesn't make sense. I wouldn't do that. So for those that don't know, proof of stake is a civil protection. You just keep hashing with Crypto Night algo to collect leading zeros in a hash. Right. But how does that help? Like, you've kind of taken something that works and made it work worse. So you've already got civil protection inherently from them being an Avalanche validator. Since subnets require that every validator on the subnet is an Avalanche validator, you know that that validator is Sybil protected off the get. You don't have to do anything else. Your token is not for Sybil protection purposes if you token incentivize your network. Your token is incentivization for people to validate your subnet. Yeah, that'd be great. I'd love to see that blog post. I just don't think that works. I don't think it works. I might be wrong. Maybe I'm misunderstanding what you're saying, but I don't think that works. So that people understand, like, Sybil protection is the ability to take pseudonymous people out there and basically just say, hey, look, this is one actor, this is one person. Well, in Avalanche, we already do that at the very base level. You have a base level Sybil protection service. That's what Avalanche is. As a platform, it has a service associated with it, which is called Sybil protection. Everybody must be Sybil protected to exist on the Avalanche network. That means that if you have a node on the Avalanche, you are already on the base layer protected in your subnets from having people who are not Sybil, like, you know what I mean? Like, you don't have to worry if they're multiple actors. Like, you don't have to worry. There's no pseudonymity. You inherit the Sybil protection from by virtue of them being Avalanche validators already. You don't need Sybil protection on a subnet. You don't. You just need to incentivize people to join the subnet. The token, any tokens that you use, any staking methodology you use on a subnet has nothing to do with Sybil protection. It has everything to do with incentivization. Which changes an argument I used to have. Damn, didn't even think about that. I'll have to think about that one. Basically, it kind of questions whether my ISO argument about whether or not subnets actually require a token. Well, they do, because you can't incentivize people to actually do anything on that network without that token. I mean, they wouldn't be... Yeah, I'll have to think about that one. That might change the whole angle of ISOs now that I think about it. So I had this article I put out about incentivize... initial subnet offerings, and it might mean that the subnets don't require the Sybil protection to be bound to their token if they're Sybil protected from the root layer already. So their token might not be necessary. Oh, but yes it is, because it causes voting rights for changes. I take that back. It actually enables, the token's necessary because the token and the staking and the validators on that stake enables voting rights for people on that validate that subnet. Let me think about that more. That's crazy. Anyway, created today a new subnet. When a friendly UI is coming, I actually have no idea. I don't like the UI for subnets either. So I'll have to think about that. Damn, sorry, I'm still in that subnet thing. Do they actually inherit the Sybil protection from Avalanche? Am I misreading that? Huh. Alright, well, maybe that actually might throw away the whole ISO thing entirely. I might change that whole argument. Oh well, I'll have to think about that. When a validator is done validating primary network, it receives the Avox tokens back into stake. So basically, these are the parameters for staking in Avalanche, and I want to go over them real quick. I think that the reasoning we used 2,000 Avox in staking is because at the time we launched the network, the value of the token was 85 cents. So this would be less than $1,000 to launch a node. Let's just say it was $1. It would take less than $1 to launch the actual node, right? Okay. Like delegation, like 25 bucks to delegate to a node. But like we jumped up to $5 in the first day. And then we went down to 3, and then went up to frickin' 30, and then 60, and then back down to 30, and then 20. Problem is the price relative to USD fluctuates a lot. And so this 2,000 of Ox could mean, which meant almost literally very little on day one of the network launch, is quite a lot now. Our incentivized test network had over 1,000 nodes on it. And each validator on that network was awarded 2,000 of Ox. That's a lot. That's a lot of money. That's a lot of moolah by today's standards. But when we did that, that was like nothing. So the problem is that people want to be validators on Avalanche, but the cost has gone up. So there's got to be some way of governing relative to fiat prices the requirement of being a validator on Avalanche. And right now, I don't know what that solution looks like, but I do think that 2,000 is a hefty toll to ask people to actually invest. Because let's just say, what's the current price? Current price is $20. So let's say, $20 times 2,000. It's like bad at math. Yeah, $40,000 US, right? $40,000 to own a node in Avalanche. That's a lot of moolah, dog. That's a lot. So we need to do something about that because we want more nodes on the network, not less. That's a car. That's a good car. That's a real good car, right? Do you want to spend a real good car on your node? Now, here's the thing. It does have an ROI that's pretty good. So it is worth the investment. But most people don't have the money to make that investment. And I think we want to democratize a lot of that stuff, right? So like 2,000 is just too dang high. The question is, all right, let's just say the price, we drop it down. 500. Boom, done, right? So now it's what, 10,000? That's still high. But what if it drops down to $13 again? Then the price to run a node becomes like less cheaper. It's like you got this real problem where the amount to run a validator should be tied to fiat because the world still exists in a fiat economy. Like there's nothing is stopped with that respect. I think another issue is you could take that 40K and earn more farming in the system. Yep. So like I'm being told that yield farming is giving better payouts than validating for a lot of people. So the thing about being a validator though is that I think that validators can get side rewards eventually, and that's why I would love for validators to that's why I love for subnets to exist, because if validators who validate a subnet get side rewards for doing very little work, not even upgrading their machines, you know what I mean? Like the subnets incentivize validators more. But then that kind of ties into the question I just had, which I thought I think subnets might inherit the civil protection that are required for Avalanche, which means that maybe the tokens aren't as utility as I thought they were. But I might be wrong about that, so I'm going to definitely go over that with some folks before I commit to that statement. This is just a dawning thought on me, that's all. Because prior to this, I thought, okay, if you were running a validator on a subnet, you also need a token to incentivize the utility on that subnet. Well, you might not need that at all. You need to incentivize people to validate that subnet. Does it count as an actual requirement for utility? Yeah, maybe. Probably. But I'm not sure. So I might need to think about that a little harder. But, you need to incentivize validators on the Avalanche subnet, Avalanche primary network to join your subnet. And that is actually attractive for validators too. If you want to be a validator, then you've got this ability to run a multitude of 10% on a multitude of tokens. And so it becomes almost like a little way of doing your own yield farming, right? By being a validator, you can validate other people's subnets and in the process get returns on that. You're doing very little extra and getting this huge ROI. And yeah, you could yield farm in DeFi, but that's very active. This is very passive, right? So you could literally just validate other people's networks and get their tokens in return. And those tokens can then, which by the way, they're net new tokens. Okay, they're net new tokens that you can actually put into something like Pangolin or whatever, and then get your DeFi sweet returns on, you know? Yield farm the crap out of them. They're net new. Just for doing work. And the work is you're running the same machine you were anyway. You got a $40,000 machine, you deposit your Avalanche in there, you get all these subnets that appear, and then you got their own tokens associated with them, and you validate those tokens for next to nothing additional over what you've already got. Maybe you got to do like a little minor memory upgrade on your machine. BFD, if you're going to be making, you know, ton of money off of it, it's worth it. It's not like buying another ASIC farm, right? So you run another, like, you get a little upgraded machine so you can run more subnets. More subnets you run, more tokens you get. The more tokens you get, the more you can put into yield farming, and it's zero cost, 100% generation. You know what I mean? Quit SBFD? Can't say it out loud, bro. I can't say that out loud. Big friggin' deal. There you go. Like, that's the angle, really. That's what ultimately the vision is. This is why subnets are such a huge deal. Like, we need subnets. If you're running a validator now and you find that yield farming is a better ROI, look to the future of what's actually going on. When you have subnets, you get tokens in return for running very thin VMs, things that do not require a lot of work. Those tokens are free. Well, not free, you put in the work and you get them as a reward. You get them back, they can go right back into the ecosystem that you're using to yield farm. Okay? That's why you run an Avalanche validator, because you will have this huge suite of subnets open to you that are willing to give you a percentage of work, some ROI for your work, and those tokens that you've gotten are now fungible assets that you can use in other yield farming applications. It's literally, it's a foundational element in good proper DeFi. So, yeah. That's why you want to be a validator. That's the real thing. Like, if you're not happy with the validator's current ROI because you're getting better returns on yield farming, I would set up I would make sure you stay above at least the minimum to be a validator, because that's where the actual money comes in, is when you're validating subnets. You know, it scales. Thing gets popular, you focus your attention from one subnet to another subnet that's popular, and the ROI will be higher. Subnets are really cool. I can't wait till they're out. You know, they're really cool.
Continuité d'homme.
At the moment, you need a whitelist subnets. Yeah, I know. It's literally just something that. Anyway, it's literally the subnets the way they are right now is they're private subnets. You know. But, you know, as soon as people discover subnets, we're good. And they're just going to be farming coins all over the place. I love this. I love this little board. Oh my god, it's so sexy. Such a sexy board. Oh, this soundboard's amazing. I love it. I love it. Y'all are watching me play with my soundboard, and you're just like,
uh-oh, retard alert!
Gotcha, bitch!
So anyway, I I really love this soundboard, but I gotta remember to use it more often, like more poignant. I think if I just occasionally do stuff like that, this pillow keeps falling off. It is driving me bat-esque crazy. Like, do you guys have a solution for that? Because no matter what I do, this pillow just falls down. Anyway. Yeah, I think subnets are going to be awesome. And I'm looking forward to it. I think the whole staking concept is just a foundational element in larger term gains for people. But, you know, unfortunately, the barrier to entry is really high right now. And I'd love a lot more people involved. You know? Definitely would love a lot more. So, delegate. I mean, delegation is actually a really reasonable... freaking God, I can't math. $20 times 25. Now, you can delegate right now and get almost full rewards for $500. You don't even have to run a node. Like, that's a good option. Like, delegate. Get your yield on that. Like, whatever you call it. Go ahead and do that. Like, delegate. If you want to be part of the network, go ahead and delegate. But yeah, to run an actual validator is kind of tough. Okay, guys, so I'm gonna do this like and subscribe thing, the whole pitch. I think this is my channel. I need you guys to subscribe to this channel. Like, I need you to subscribe and follow and all that stuff. I'm still a noob at all this stuff. Hit that little subscribe button right there. You hit that button, and then you ring the bell, and that makes my life easier. I wanna pump this channel out a little bit more. Definitely, like, any subscriptions or stuff you do for Twitch is awesome. I don't make my money off of this. Yeah, that's great, Shellbro. Perfect. I don't make my money off of Twitch subscriptions, but what I do is I need this to raise my social rank because I'm trying to get more people to view this stream. And the reason I'm doing that is because this is literally, for me, an educational... It's fun, okay? That's why. I want more people to watch. I want people to learn about Avalanche, and that is how I really get paid. I really get paid by more people liking what we built. Like, what we built is amazing, and I want more people to know about it, but there's definitely a barrier to entry in understanding this stuff. And I want to be part of helping that. I left the company Ava Labs, but I'm still in the community Avalanche. So smash that like button and subscribe. Every little bit of money you give Twitch, they notice me. So, like, it's just a matter of boosting that profile. And by the way, like, there's a lot more work to be done. There's so many people with like hundreds of views on the crypto channel on Twitch, and I'm just like, they're talking doo-doo. Oh, the Discord link expired. I actually am thinking of ditching the Discord and going straight to Telegram. So I wouldn't worry too much about that right now. I'll fix all this stuff this weekend. This is my job now. I love my life. It's great. Like, this is what I want to do. So, you know, like, I'm going to be working on iteratively improving things, but one thing I got to improve is the community building stuff for this. So I'll do the Telegram. I'll get that going. Get that Telegram going. And, you know, yeah, Discord's great and all, but, like, at the end of the day, it's like, I don't want to manage a Discord, and Telegram really is a lot easier to manage. So, yeah, I'll do that. I'll set up a Telegram. Plus, that's where all the crypto nerds are, even though I'm not. So, yeah, I'll do that and update all that stuff. Dang! Thank you for your Twitch Prime subscriptions. Look at all you guys. Give me all them subs. I appreciate it. Appreciate you. Appreciate you helping me out. Look, like I said, I'm probably going to be... there'll be a little cessation of this weekly tech stuff, but I'll do the Tuesday and Thursday. Continue to do that. I'd like to integrate other stuff, but, like, it's a matter of content for me. Like, how long can I sit here and talk to you guys on screen and just blabber on about my ideas and stuff before it gets old and boring? And I really do feel like, you know, 4 to 6 hours a week is about the cap I can do. But 4 hours a week is all the content I have on a reliable basis. And then from a tech perspective, I can pull out 2 to 4 a month. 2 to 4 hours a month and still be able to stay fresh. So, you know, long story short is I don't know what to do with regard to that. I don't want to drop the tech stuff, but at the same time, I don't know how I can keep this up. So I'll think on that. If you guys have ideas, you know, please reach out to me. I'm very interactive and open, and, you know, talk to me, and I'll talk to you, and we'll figure stuff out. I love ideas, so just give me some ideas and stuff. And with that, I'll bid you all a doo-doo, and I will see you guys next time. And I appreciate you, and I hope that you have a wonderful day, and I will see you tomorrow. Same bat time, same bat channel.